papers. Okay, so good morning. So today we will discuss about now the adiabatic process and the different adiabatic, the isentropic, and the polytropic processes wherein kailangan natin siya sa steam table or sa steam Rankine, the different Rankine cycles. I mean the steam simple Rankine cycles, the acute, the actual, the ideal, and the heat regenerative cycles. Okay, we'll start now. Okay, nakikita na ba class? Ayan. Okay, we continue now class sa adiabatic process. Okay? So, ano nga ba ang adiabatic process? So, just a review, we discuss about the constant volume, the isometric, the constant pressure, the isobaric, the constant temperature, or the isothermal. So, now we proceed now to adiabatic processes. Okay? So, automatically we have the PV and the PS plane. Okay? So, reversible process. Okay, so, sulat natin. We have the pressure and specific volume. So, palagi ganito class. And the TS. The TS type. Sa taas siya. Yeah. Class in a reversible adiabatic process, ang nangyayari class is a constant entropy. Pag ginabing adiabatic class, constant entropy. Yung S natin is constant. Okay? So, proceed to the figure. Tayo, so given yung pressure 1, and pressure 2, and from point 1 to point 2, kadalasan class superheated yung vapor niya, kadalasan lang. But take note, it depends upon the problem, okay? Kung ano yung binigay sa atin na situation, lalo na sa problem. So, kadalasan ganito po siya, class, from point 1 to point 2. So, this is an adiabatic process. Since constant entropy siya, class, mangyayari sa ating sa TS diagram. Ganito, class, sa TS diagram yung constant pressure. And at pressure 2, and this is now your pressure 2. Since this is a constant entropy, ito class, yung is equal to constant automatically from point 1. Ayan. From point 1 to straight line lang yan kasi constant kayo ng entropy natin class. given sa atin dito yung temperature at point 1 and the temperature at point 2. Ayan, diretso lang yan. Okay, so this is now the PV and the TS plane of an adiabatic process. Okay? Ulitin ko lang yung constant entropy process natin. Ang tawag doon is the adiabatic process. Okay? Since adiabatic process siya, automatically class in an adiabatic process. Okay? Ang adiabatic class is sometimes called isentropic. Ayan. Pwede siya isentropic. Tropic process. Pares lang yung concept natin. In an isentropic process class, so automatically ang notation natin dito class, pag sinabi sa problem na adiabatic process or isentropic process, automatically there is no heat transfer. Okay? Automatically, yung Q natin is equal to 0, yung heat natin. And also, since entropy natin is constant, the change in entropy is always equal to what class? The change in entropy?
0
of the substance. Okay, thank you. So it's always 0. So automatically we have the change in S equal to 0. Yan. So meron na tayong basihan. Pag sinabi sa problem na adiabatic process or an isentropic process. Okay? So, paano naman yung sa work class? Work. Okay? Paano yung sa work? So, for a non-flow process, yan, yung process natin, balik tayo sa general equation, energy equation, change U plus the work of the non-flow. Automatically, in an adiabatic or an isentropic process, your Q is always equal to 0. Okay, yan yung palagi yung tatandaan. Then, we have the non-flow work now is equal to the negative change in U, or the work of the non-flow is U1 plus U2. Okay. How about for a steady process? Steady flow process. Okay. So we have now work S, assuming that the change in potential energy is equal to 0. Okay, take note, general equation natin, kinetic energy at point 1 plus the enthalpy at point 1 plus the heat added and the kinetic energy at point 2 as well as the enthalpy at point 2 and the work of the steady flow. Okay? With that, although in adiabatic or in isentropic process, our heat transfer is always equal to 0. Deriving the equation, we have now here the work of the steady flow process. We have now the enthalpy at point 1 minus the enthalpy at point 2 minus the kinetic energy. Hence, kung ang given sa atin kadalasan, pag walang kinetic energy sa condition na 0, na-assume mo siya, kadalasan ng work ng steady flow natin in an isentropic or in an adiabatic process is equal to the H1 minus H2. Yan. Okay? So, yan yung steady flow work natin. How about the irreversible process? So, this class, this is the reversible process. This is the reversible process. Yun ha. Sa reversible yan, class. How about in an irreversible process? Okay. So, dalawang condition yung class. We have the reversible and the irreversible process. Ayan. We have the irreversible in an adiabatic and an isentropic process. Okay? So, ganun pa rin class yung PV and TS play natin. Hindi yan kasi kadalasan nagbabago. So, dapat kamay nyo na to. Drawing the PV as well as the TS diagram. Okay, the TS diagram of the steam. Okay, take note sa reversible process class. Meron na tayong tinatawag na actual. Okay, we have now the actual processes. So, ganito yung class. So, given sa atin 0.1, yung pressure natin constant. Mali. Okay, take note. We have here pressure 1, assuming that it falls here. Pressure 1 and pressure 2. Okay. Ayan. It's like what? Okay. Sa pressure 1 class, kadalasan state point natin is from point 1. So, this is the reversible process at point 2. Ayan. Naglalag ba class? Naglalag ba ako? Class. Lag ba ang aking nag-guess?
Hindi man po, ma'am.
Ayun. Ow. Ayun, internet ko ata. Okay. Okay. From point 1 to point 2, we have now here, this is the reversible process. Take note dito, class. This is now the irreversible. Kapag ganito na class na dotted line, this is now the irreversible process. So, may tinatawag na tayo 2 prime. Okay, that is now the irreversible adiabatic process. Also, in point 2, same lang naman class from the pressure at point 1. Yan ang pressure at point 1 and the pressure at point 2. Yan. Ganito class yung pressure natin. So, from point 1 to point 2, what is now the point 1? So, dun pa rin tayo. At point 1, ayan. This is your point 1. Ito yung reversible process natin. And, balik tayo doon. So, this is now your irreversible process. May 2 prime ka na class. 2 prime. So, that is the irreversible process. Bakit kailangan natin yan class? Because during the computation of the actual Rankine cycle, the actual reheat cycle, actual reheat regenerative cycle. So, gagamitin natin itong mga 2 prime. Okay? So, yan. This is the irreversible. So, sulat natin. This is the irreversible Okay, class, wait lang, nawala yung connection ni ma'am. Umulan kasi ng malakas. Okay, wait lang class, set up ko. Na-rejoin din ako class sa Gmeet. Ayan. Naririnig na ako class? Po?
Yes po.
Yes po.
Naririnig na si ma'am? Thank you class. Pasensya class. Umuulan kasi ng malakas dito sa atin. Ayan. Okay. Okay, nag-join pa ang aking. Waiting to join po class. Ating. Wait lang class, naglalag pa ang aking. Okay, so balik tayo dun class. So we have now the irreversible process and the reversible process. Okay? Ayan. Okay? Makikita na ba class? Hindi pa. Mahina yung internet ni ma'am. May nakikita ba kayo class? Yes or no?
Ako po.
Wala po, ma'am.
Meron.
Wala po.
Okay na class? May nakikita na kayo?
Yes po.
May nakikita na. Okay. So, thank you class. So balik tayo. We have now the reversible process and the adiabatic process. Okay? So from point 1 to point 2, we have the reversible process. Okay? 2 prime, I mean from point 1 to point 2, meron ka ng adiabatic. Okay? you have your adiabatic or tinatawag nating isentropic process. Okay? Okay, class. Nawala na naman ako. I'm using my data. So, balik tayo dito, class, from point 1 to point 2, the reversible and the isentropic process. And from point 1 to 2 prime, ayan, ayan. We have now the irreversible. Ayan. This is now the irreversible process. The irreversible adiabatic process. Or tinatawag na natin, this is now the actual expansion. Tawag niyan, class, is actual expansion. Pagpaganyan. Yan. Pagpapunta doon. Point 1 to point 2, expansion yan, class. And this one from point 1, this is ideal expansion. This is now your ideal expansion. Okay? So, nag-stick ba yung class? Presentation ko.
Opo.
Ayan. I-connect ko lang sa aking. Wait, class. Okay na, class? Okay. Pumagalaw. Pumagalaw ba? Hindi. Okay, we continue, class. And so we have now for an ideal expansion that is from point 1 to point 2, that is reversible or isentropic process. And from point 1 to point 2 prime, that is a reversible adiabatic process. Okay. So if we have a non-flow process sa reversible process, we have also this one, the non-flow process in an actual expansion or in an irreversible adiabatic process. So, alam natin, pag adiabatic, automatically your Q is 0. Ayan. Ayan. So, we have here the Q, the general energy equation. We have the Q is equal to 0 automatically. So, mangyayari, class, this is a general equation. Ayan. Ayan. Nakaka-connect na. We have now the Q is equal to the change in U. We have now the so-called prime, the U prime, plus the work of the non-flow. Okay? Kasi mag-iiba na, class, yung state 2 mo dati from U2 magiging U2 prime. Okay? Ayan. U2 prime. Ayan. So we have also here the now the work of the non-flow that is now equal to the negative of the change in U prime. Okay, ito yung mga babagong state points mo dyan, the U2 prime. Okay? Yan. Magiging change in U prime mo is from U1 prime. You can have this or U2 prime. Okay? At that state point. And we have also for a steady flow process here in an irreversible. Yan. We have now the work at the reversible. So kanina we have the enthalpy at point 2, point 1 and point 2. This is the reversible process. Then in a irreversible process, we have now the steady. Yan. May prime na ulit tayo, class. We have now the H1 minus H2 prime. Okay. This is now the irreversible process. Okay. Yan, naglalag. Yung sulat ko. Okay, so that is the work on a steady flow process or in irreversible. So, H2 prime class yung mangyayari dyan. You have now your H2 prime. Ayan. Hindi gumagalaw. Ayan. Anyways, makinig na muna kayo, class. So, if we have that, meron din tinatawag na efficiency of the process on a HS plane. Okay? Ayan, naglalag talaga siya. Ayan na. Okay, meron na. Okay. We have the efficiency of the process. Ayan. So, mangyayari to, class, na expansion sa molar chart nyo on HS plane. Ayan. Okay? So, mangyayari yan. So, draw mo lang, class, yung molar chart natin na HS. Ayan. Siyempre, wala pa dyan sa screen nyo. Kasi may na-internet to. Okay? So, sa HS process natin, class, you have this. Okay. So, mangyayari, class, balikan natin different processes. Meron ka ditong process 1. Ayan. Wait, class, i-connect ko sa aking cellphone tong iPad para madali. Wait, class, i-connect ko lang siya sa... Okay, so, mangyayari, class, balikan natin different processes. Meron ka ditong process 1. Ayan. Siyempre, wala pa dyan sa screen nyo. Kasi may na-internet to. Okay? So, sa HS process natin, class, you have this. Ayan. Okay, andito na ulit ako class para mas madali. Balik tayo sa notes. Ayan. Para malakas yung... May feedback class? May nakikita kayo? Wala.
Wala po.
Ayan. Wala. Bakit tayo? Nag-connect na ako class sa PLDT tapos GlobeMate. Wala. Okay. Wala talaga. Ayaw. Bakit ayaw mo? Okay na class. Ayan. Okay, balik tayo dito sa efficiency ng HS. So, sabi ko nga, ito class yung point 1 natin sa molar chart. And also point 2. Given sa atin yung pressure at point 1 and pressure at point 2. Yan, hindi na siya nalalaan. Okay, so, since this is adiabatic process, constant natin. Constant kasi yung isentropic natin. So, from point 1, for example, this is now your point 1. Okay. Pababa siya. Straight line in class kasi constant yung S1 natin is equal to S2. This is now your 2 and this is now your irreversible state point at point 2. So, ang tawag dito class, from 2 to 2 prime is reheat. Yan. Tandaan nyo yung class. And also from in the vertical line, reheat class. But from 2 to 2 prime, horizontally, ang tawag doon ay irreversibility. Okay? Tawag dito is irreversibility. Irreversibility. Ayan. Tandaan nyo to class kasi during the the different cycles, magagamit natin to class. Okay? Bakit kailangan natin to class? We need to compute for the efficiency. Yeah, this is now the efficiency. Noted as N. Okay? Yung efficiency natin, ganito class. N. Malaking N. So, this is the actual work. When it comes to irreversibility class, the actual work over the ideal work. Yan. Para makuha mo yung efficiency natin, mostly ginagamit is the steady flow process of the work, okay? Work of the steady flow process. We have now the H1 minus the H2 prime over the ideal class, yun dati lang. H1 minus H2. Okay? But take note, yung H2 prime natin, bakit squared? Ayan. The H2 prime minus H1, I mean H2, from the given, dito class
sa ating HS plane, makikita niyo is the reheat, di ba? Ito class, oh. Makikita niyo, this is the reheat. Ito po, ito class, oh. This is H2, di ba? Yung reheat natin class, pag diniretso mo yan, that is now H2 prime. And this is now your H2. Okay. And so, ang tawag ng class is the process of the internal reheat. Okay? Pag kinuha mo to, the H2 prime and the H2, as well as sa baba class, ito, the S2 and the S1, S2 prime. Makikita nyo din yung S2 prime natin. You have the S2 prime minus the S2. This is the actual. This is called the irreversibility of the process. Yan. This is the HS plus molar chart yan class. So we have now the different equation used in the expansion of the. This is called class expansion. How about compression? Sabi ko nga kanina class, pag ganito from point 1 to point 2, from point 1 to point 2, makikita nyo this is expansion. But when it comes to this point, yan, assuming papunta doon, pataas yan class. This is compression. Okay. Pagpataas, point 1 to point 2. Okay, assuming meron ka dyan, 2 prime. Okay. So, we have the expansion. Meron din tayong compression sa HS plus. HS plane pala. Ayan. Anong nangyayari sa compression on HS plane? So, depende yan class kung paano dinescribe sa problem. You have here, yan, the HS. Samantalahin natin habang mabilis ang ating internet. Have here the pressure at point 1 and the pressure at point 2. Considering we have point 1 here, yan, sa baba class, and 16. Since this is an adiabatic process, this is a constant. S1 is equal to S2. But since this is a reversible process, meron ka ditong 2 prime. So, ang tawag nito class is compression. So, when computing for the compression, okay, anong pinagkaiba niya? Sa efficiency of compression class, take note, this is N. So, you have also the ideal work. And dito class, baliktad na. You have the ideal work over the actual work. Okay? Yung ideal natin is H1 minus H2. And on the other side, yung actual pa rin natin, H2 prime. Okay? Times 100% kasi efficiency siya class. Okay? So, we move on to the sample problem in a adiabatic process. Okay? Hanap tayo ng example. Madali-dali. Okay? Ito na lang. Mga 2 page. Okay? So, Dito tayo, class. Sa may efficiency. Excuse me. Okay. Ito. Okay, for example, class, we perform this. Okay. Example, sa adiabatic process. Okay. Steam turbines. Yan, turbine na to, class. Receives 0.52 megapascal of steam at 300 degrees Celsius. Then expand in an irreversible adiabatic process. Yan. So, stated sa problem na irreversible siya to a pressure of 0.012 MPa. Yeah. If the exhaust steam is dry and saturated, we need to calculate letter A. Ano yung kakalculate natin? The work of an irreversible process and the efficiency. Yeah. We have here the efficiency of the process. Okay. So, the solution. Okay, first, mamaya na i-draw yung okay, first, we need to find are your steam table with you? Raise your hands. Okay. Okay. Calculators. Okay. So, first one, class, draw muna natin yung TS. I-draw nyo na muna, class, yung basic natin. Sa solution, palagi na yan na may TS. Okay. TS muna. This is the TS diagram. So, mamaya, bago tayo, hindi pa natin alam yung mga state points. But, since the exhaust steam is dry and saturated, ibig sabihin, class, 100% vapor siya. So, nasa linya siya. Okay? Pero mamaya na. Doon muna tayo sa pressure 1. Finding the state point at point 1. Okay, given sa atin, pressure 1, which is equal to 0.52 MPa. And the temperature at point 1 is 300 degrees Celsius. Small letter pala. Di pa siya in absolute. Okay. Saan kayo pupunta? At point table point 52. Table 2, since given sa atin yung pressure, table 2, ayun, nakuha ko na. Point 52. Makikita mo, anong table, class? Saka sa table 2,
po.
page 10. Yung saturated temperature niya is equal to 153.34. Automatically, your T temperature at point 1 is greater than the T sat. Ibig sabihin yan, superheated vapor. Okay? After that, go to table 3. Anong page? Page what? 0.52. Mag-interpolate na ba tayo? Page 31. Ayun, no? Eksakto. Yes, class. Oh, this is page 31. Okay. Anong hahanapin nyo, class? So, andito na lahat. Given na sa atin kasi superheated vapor na siya. Hindi tayo mag-interpolate. So, 0.52. So, ganito sa taas. 0.52 sa taas. Hahanapin nyo sa gilid yung temperature na 300 degree. So, ayan na. Papunta doon. Papunta dyan. So, mahahanap na natin yung state point, yung specific volume at point 1. Ano yung specific volume at point 1? So, 502.2. The U1 or the internal energy at point 1. We have also 2802.6. And the enthalpy at point 1. Tama ba klase, ma'am? 363.
Nagalag po, ma'am.
Ayan. 0.3 kilojoule per kilogram. Okay? Okay, so we have now the entropy at point 1. Ayan. The entropy at point 1, we have now 7.4411 kilojoule per kilogram Kelvin. Okay? Okay, so meron ka ng state 1, points at state 1. And balik tayo dito sa problem. Then, expand in an irreversible adiabatic process to a pressure of 0.012 MPa. Yan. If the exhaust steam is dry and saturated. So, from the problem, class, as stated at the problem, you have the dry and saturated. Ibig sabihin, 100% yung quality natin. Automatically, yung mga saturated vapor natin yung kukunin. And this is a irreversible process. Okay? At point 2 prime to class ha. 2 prime. Kasi irreversible process siya. Sinabi dun sa problem, magiging 2 prime siya. Naintindihan, raise your hands. 2 prime siya class kasi stated sa problem. Okay? So, this is now point 2. Punta tayo doon sa pressure 2 prime. Huwag yung kakalimutan yung prime. That is 0.012 MPa. Since dry and saturated, automatically, anong page tayo? Balik tayo dun sa page. Table 2. Table 2. Table 2 tayo, class. Table 2. Anong page? 0.0012. 0012. Okay?
Page 8
This is,
po.
thank you. Table 2, page 8. So we have now the different values of the specific volume. Pakita ko lang class yung kung ano yung kinukuha. The Vg, which is now equal to the Vg2 V2 prime, that is equal to ilan to? Baka naduduling ako. Ha? This is 13,415 times 10 to the negative 3. The internal energy at saturated vapor is equal to, ay mali ako, 0.12. Ayan, mali to. 0.12 pala, class. Nadulo ako. Yung ruler ko nga saan ko. 0.12 MPa, this is 1231. 12,361.
0.361 po.
Ayan. Thank you. And yung internal energy natin at dry and saturated, this is 0.12. So we have the internal energy at 0.2. This is equal to 2,442.7 kilojoule per kilogram. And yung enthalpy natin at 0.2 at irreversible process is equal to 2591.1 kilojoule per kilogram. And last but not the least, 2591. Nasaan ako? The entropy at that prime at that irreversible process is equal to 8.0863 kilojoule per kilogram keratin. Okay. So, pinakita lang class ni ma'am kung paano kumuha ng mga different state points. Okay? At the irreversible process. Okay? So, take note, if the problem is the irreversible, how about, sabi ko muna, we need to compute for the reversible process. Ano yung gagawin mo? Given sa atin yung, since yung pressure class, automatically, parehas lang yan. It will lie on the same pressure. I mean, it will exist on the same pressure. Pressure 2 prime is equal to pressure 2. Okay? Parehas lang yan, class. But, considering that this is an isentropic process, we all know that S is equal to, is constant. So, S1 is equal to S2. Ang gagamitin mong guide, class, if this dry and saturated irreversible process is not stated in the problem, ang kukunin mo is yung from S1. Diba? What is S1? This is 7.4411. Ayan. Hanapin muna natin, class, yung quality nito, class. Quality. Okay? Bakit kailangan natin yung quality? Kasi, from the, nakita naman natin yung SG natin at this pressure is 8. So, mas malaki siya. So, this is in between. Okay? Para ma-drawing mo, class, dun sa PS diagram na. Okay? Okay, find the quality, class. Ano yung gagawin mo dito? Kukunin mo lang si SF at 0.2 and SFG at 0.2. Let's say we have this is equal to entropy at 0.2. So, 0.2 plus X at 0.2. Yan. Hanapin mo yung quality at this point. Anong kukunan mo dyan? That is on pressure 0.012 MPa. Okay, sa steam table mo, this is 7.44. Kasi given siya. Class ha, reversible process yung pinapakita ko dito. Reversible process. Okay. What is your SF at 0.2? 0.12. Nakuha ba, class?
0.6963
Okay.
kilojoules per kilogram Kelvin.
And also your SFG, that is 7.39. Okay. Try to compute for the quality, class, at 0.2. Sige nga. At 0.2. 0.2, what is now the quality at this point? Class, calculator. What is your quality, class?
91.27% po.
Okay. That is correct. We have 91.27% or 0.9127. Okay. Thank you. So, bakit pinakita yun ni ma'am? Kasi, ang hahanapin natin dito is also the H2. Okay. Bakit kailangan natin yung H2? Kasi when we compute for the efficiency of the process, we need the ideal work and the actual work. Okay? Kasi tanong yan, class, dito sa problem. The efficiency of the process. Okay? Dalawa lang naman pinapahanap niya. Okay? So, finding the H2, we have HF2 plus the quality at 0.2 and the HG. Okay? Ano yung HF2 nyo? At the same table. Ano yung H2 nyo?
6 point... Ay, H2. Ah? Akala ko ma'am HF2 po.
HF2. HF2.
206.92 kilojoules per kilogram po.
Okay, 206.92. And the quality, class, use now the nakuha natin times the HFG2. This is 2384. Yeah. Kilojoule per kilogram. So what is now your enthalpy at 0.2 at the reversible process? Okay. What is now your H2? Okay. Ayan. 89. Okay, lahat ba nag-compute? Baka yung iba lang. 91.27. 2384.1. Yes. 2382.89 kilojoule per kilogram. Okay. So, in solving this example, we need to find now the, what is letter A? Pinapahanap sa atin is the work of an irreversible process. The work of an irreversible. Yes. So what is now the work in an irreversible process? Ay, nakalimutan natin yung prime. Automatically, we have the H1 minus the H2 prime. H1 natin. What is H1? That is 363.7. 363. And the H2 prime. What is the H2 prime? Ito, class. 2591.1. What is now the answer in an irreversible? Sige nga, in an irreversible process. What is now the answer? Minus 2591.
472.6.
Okay. Yan. We have now, yes, 472 kilojoule per kilogram. Okay. So we have now solved by point ka na dito. Point 1. And in letter B, the efficiency of the process. Since this is an irreversible, process, we have the efficiency of this. Ano nga yun, class? Pag ganito, we have the actual work over the ideal work. We have now the H1
Permission to
minus...
interrupt po.
Yes po.
Ano po yan ang symbol sa ano po?
This is N. N na may ganyan, class. Kalimutan ko yung ang tawag nito. This is efficiency. Okay. This is efficiency. Pag ganyan yung class sa mga libro. Okay. So this is now the efficiency. The H1 minus the H2. H2 prime. Actual pala. Over the H1 minus the H2. This is class the actual. This is the ideal. Okay. Finding for the efficiency. Efficacy pala. Efficiency. So we have now, alam na natin yung sa taas. Kilojoule per kilogram. Sa baba, class. H1, we have 363. 63.7 minus the H2. Ito, class. In a reversible process. 2382. 82.89 kilojoule per kilogram. So we have now the efficiency. What is now the efficiency? 69.41. Yung iba, 42. Okay, yung iba,
69.42% po.
Parang hindi mo ito, 680 to. 81 kilojoule per. Ayan. 72.6. Ayan. 62. Ilan? Ayan. We have now 69.41, 42. 42%. So we have now the efficiency. Okay. So nakuha na natin yon, but babalikan natin si TS diagram natin. Okay. Since from point 1 sa TS natin, class, this is your pressure line. Ay, mali man. Ayan. This is pressure 1 and the pressure at point 2. Ganito yung straight line. And that. Okay. This is pressure 1. And this is the pressure 2. Okay. Since na-determine natin at pressure 1, that is a superheated. Doon siya sa labas. Point 1. And stated, we have now the at point 2, this is the ideal. Okay? Bakit hindi? Straight line dapat yung class, straight. Okay? Para makonsider natin S1 is equal to S2. And so, base sa problem, at point 2, at irreversible process, it falls under the category of a dry and saturated vapor. So, dito siya class, dito siya sa saturated line natin. From the saturated vapor line, dito siya magfo-fall. Okay? Diyan mismo. So, we have now the point 2 here, 2 prime. So, this is now your irreversible process. Okay? So, may 2 prime ka na dyan, class. Kasi dyan siya nagfo-fall. What if magfo-fall siya sa superheated vapor, class? Pag sinolve mo, automatically, kung hindi dyan, papunta dito yon. Kadalasan yung 2 prime. Okay? Ayan. But since the problem is stated is dry and saturated, so yan yung magiging basehan mo. Okay? Erase ko lang to. Baka malito kayo pag sa solution mo. Okay? So that is now your adiabatic process. Okay? You have now the PS and the, yung PV natin. Dali-dali lang yung class. Okay? Kung ipi-PV mo to, class, the problem number 1, okay? Sa problem number example natin, yung PV niya, class, magiging ganito. Yan, specific. And pag ganito yan, yan. So, since sinabi sa problem, pressure 1, and pressure at point 2. Now, this is your pressure 1, pressure 2. Superheated, sa labas siya, class, point 1. This is a constant. 2. Ay, mali. Specific volume pala to. PV, so, magiging mali kayo dito, class, pag in-straight line nyo to. Okay? Okay? So, ito lang, class, yung mali dito. This one. Okay? So, since this is a PV diagram, automatically, pag ganito siya, class. Bakit erase? From point 1, pag ganito siya, magkukurba siya, class. 2.2. And yung sa 2 prime natin, let's make ganito siya. Ayan. 2 prime. Kasi, sa state 2 prime nyo ba, class, makakuha mo dyan is yung VG natin. So, VG. Okay? And the specific volume at 2 prime. Okay? This is now your PV in this adiabatic and adiabatic process. Yung heat mo ay 0. Kadalasan tinatawag na isentropic process because your entropy is constant. Papasok si irreversible process. You have now the actual expansion. Yan class yung mga keywords about these processes. Actual expansion. Okay, irreversible process. May prime ka na, class. You have U2 prime, H2 prime. The specific volume at 2 prime. And ano pa yung kulang ko? Yes, the entropy at the irreversible process. Okay? So, may question pa ba ka sa irreversible process para makamove on na tayo sa the polytropic process. Okay? May question pa, class?
Mami, nagpatanong po, bakit daw po curved yung line sa PV?
Okay. Curve yung line natin dito sa PV kasi from process 1 to point 2, hindi constant class yung irreversible natin. Yes. Hindi class pag in-straight line natin yung class, dito tayo. Pag in-straight line ko yan, yung point 1 to point 2 sa PV diagram natin. This is your PV diagram. Automatically, ang mangyayari, you will have an isometric process. Okay? Hindi na siya isentropic process. Okay? Ganyan, class. Pag mga kurba yan, pag mga expansion, pag ganyan, class. Expansion. And, bakit? Magiging expansion to. Expansion and papunta doon is, kadalasan is compression. Okay? Hindi pwedeng straight line sa PV kasi ang mangyayari, yung process mo is an isometric process. Magiging specific volume and at point 1 and specific volume at point 2 is equal. O magpo-fall siya sa isometric. Curve line siya, class, as well as yung sa ibang processes. Okay? Hindi siya nagpo-fall na parang pressure 1 at point 2 and compare sa isothermal class na you have this point 1 and point 2. Okay? Kasi class yung sa isothermal natin, balikan ko lang, yung sa isothermal natin, yung sa PV na example ko doon, the pinakauna, is from saturated, given sa atin yung dalawang pressure 1 and pressure 2. So, dito siya galing, papunta siya dito class, point 1 to point 2. So, kadalasan, dumadaan muna siya dito. Okay? Pag compression, or kadalasan, makikita nyo is from point here, point 1 to point 2, dito yun. Hindi kadalasan na compression sa isothermal. Ayan. O yan ito. So, hindi yan. Sa isothermal class, palagi siyang dumadaan dito sa state points niya. And dito, another example sa isothermal, nakita ko dito. From point 1 to point 2, may ganito. Ayan. Palaging may kurba. May straight line. Point 1 to point 2 sa isothermal processes. Okay? So, madami-dami class ang kailangan nating i-familiarize, lalong-lalo na sa PV and the TS diagram. Okay? So, dito class, huwag kayong mag-straight line dito. Kasi pag in-straight line mo to, automatically, you will fall under the process na isometric. Okay? Mag-iiba yung solution mo niyan. Okay? Curve line talaga kadalasan sa PV. Lalong-lalo na sa adiabatic and the isentropic processes. Okay? Lalong-lalo na yan, class. Curve line. Okay? Kasi may expansion and the compression ang nangyayari sa mga irreversible adiabatic processes. Okay? Naintindihan na, class? Or mas lalong naguluhan? Okay? Naintindihan ba or naguluhan? Okay, so madami-dami pa to, class, na processes. So, ganyan class sa PV. Okay? Kaya kadalasan, in solving problem, ang hinahanap is the TS diagram. Kasi mas madali i-represent sa TS diagram yung mga state points natin. Okay? Ayan. Isentropic expansion, adiabatic process, isometric. Okay? Okay, may question pa? Sa isentropic. Ayan. Madami-daming readings pa dyan, class. Okay? So, we move on to the polytropic process. Okay lang ba? Move on na tayo sa polytropic process. Anyone? Okay? Kung meron tayong isentropic, we have now the polytropic process. Okay, pang ilan na tong process? Madami-dami na yung class. In a polytropic process class, meron na tayong tinatawag dito PV is always raised to N times C. Yan. Babalikan mo to dito sa ideal gas law. Okay? This was derived on the ideal gas law during N, where N is equal to 1, 2, 3, so on and so forth. Okay? In a polytropic process. So, given dito class yung equation mismo, pag nakikita mong may ganito sa equation, given palagi yan, yung N mo yan, makukuha mo yan sa problem. Okay? Sa polytropic process. Ano lang pinagkaiba niya? When solving these processes, okay? So, sa polytropic process class, yung process ng PV, and TS natin, ganito, parehas ng adiabatic and an isentropic. Ayan. Yung PV natin pa ganyan. Okay? So, here, assuming yung pressure 1 natin. Ayan. We have here the pressure 1. And at pressure 2. Considering this, pag ganito class, sabi mo, bakit kurba? So, we have here 1 and at point 2, bawa dito, kurba yan class. Papunta ditong point 2, ang lapit class. Erase natin. Yeah. From process point 1 to point 2, ang tawag nito class is the PBN. Pag ganito class, nagkukurba. Pag nagakurba yan class, ang tawag dito is PV raised to N is equal to C. Yan. Bakit kadalasan kumukuha ka dito ng straight from point 1 to point 2. Ayan. From point 1 to point 2, may makikreate kang shaded portion. Sabi ko nga, itong shaded portion when it comes to PV diagram, ito class, itong shaded portion mo, automatically makukuha mo yung, kuha ka dyan ng isang strip, di ba? In your integral calculus. Di ba? Yung ito, mangyayari dito, kinuha mong strip, this is your constant P, and this is your differential V. Okay? So, ito class, may work na nangyayari dyan sa non-flow. Sa polytropic class, in a polytropic process, okay, letter B, in a polytropic process, using that, pag dinerive mo yung class na equation na yan, okay, yung work natin sa non-flow, work of the non-flow process We have this work N. Okay. The polytropic process is defined as the PV raised to N is equal to C. Okay, in an equation. So, we have now the work of the non-flow. You have to integrate the PDV. After integrating this, anong mangyayari? So, a very long process, shortcut na lang natin. We have now the P2, V2 minus P1, V1 over 1 minus N. Okay? So, ang gagawin nyo dyan, class, convert nyo dito yung P, Vn natin is C. I-infuse mo yan dyan, automatically makukuha natin. Okay? So, we have now the equation of a non-flow process. And we have also the transferred heat. Meron kasi ditong transferred heat. Okay? In a polytropic process, your Q, so hindi naman sinabing adiabatic process or isentropic. Since this is a polytropic process, we have the heat produced, we have the change in internal energy plus the work of that non-flow. So we have now here the U2 minus U1 plus this one, polytropic work of the non-flow, 1 minus N. So this is now your equation. And also we have the work on the steady flow process. So balikan natin, we have the Q minus the change in S minus the kinetic energy. And sa work in an isentropic in a steady flow process, pag in-integrate mo yung class, binaliktad yon, automatically we have the negative integral of the specific heat, specific volume over the differential P. Okay? Mangyayari, class, sa steady flow, baliktad na siya. The P2, V2, ito class, P1, V1 over the 1 minus X. Ayan. Or, shortcut, we have now the efficiency. I mean, not the efficiency. The N sa PV raised to N mo is equal to C times the work of the non-flow. So, ito class yung kadalasan ginagamit dito sa polytropic processes. Okay? In a steady flow process. So, how do we compute this polytropic processes? Mas madali nga ito, class. Okay? Bakit? Kasi we'll use the, how do you call this? The equation given in the problem. Okay? For example, okay, para mas maintindihan niyo yung polytropic process. Ito lang kasi palagi yung tatandaan pag may polytropic process. Okay? Sabi dito, we expand the 2 kilogram of steam at 15 bar. Okay, mag-convert pa tayo. 300 degrees Celsius into the wet region. Di ba? Dapat alam niyo kung ano yung wet region to 100 degrees Celsius in a polytropic process where PV 1.21 is equal to C. We need to determine the, ano yung i-determine natin? We have the percent moisture, the change in enthalpy, the change in entropy, in the non-flow, and the steady flow work, and the heat. Okay. So, solution. Mamaya na yung PVMTS diagram nyo. So, alam naman natin, given sa atin is 15 bar convert it into MPa. Sige nga. What is the conversion of 15 bar? 1 bar is equal to how many MPa? Oh, class, 1 bar. 1 bar is equal to 1,000 kilopascal, or 1 bar is equal to 0.1 MPa. Okay? So, 15 times 0.1, automatically you have now your excuse me, 1.5 MPa. And we have now the pressure at point 1, a 1.5 MPa. Temperature at point 1 na given sa problem is 300. Punta ka doon sa table 2. Tingnan mo yung saturated. Temperature niya. Okay, pressure to 1.5. Ilan yung saturated natin?
198.32.
Okay, we have now 198.32 degrees Celsius. We have now the Tsat. And having that, we have now the given temperature is greater than that of that saturated vapor. So this is category, this fall under the category of superheated vapor. Punta ka na doon sa table ano class? 3 page ano? Page what? 1.5. Saan na yan? 1.5. Ayan, 1.7. Page ano? We have 1.5 exacto. Page 42, thank you. Okay, so find out. So sa page 42, makikita mo sa taas 1.5 MPa. Punta ka ulit dun sa 300. And makukuha mo na yung different properties niya. So at state 1, ano yung makikita mo? Yung specific volume at 1. We have 169 times 10 to the negative 3 cubic meter per kilogram, negative 3. The H1, internal energy. Yan. Wala akong internal energy. We have now 2783.1. Tama ba ako, class? H1, 37.6, S1, 6.91. Tama ba, class, yung mga nakuha ko? Kelvin. Ayan. So we have now the state at point 1. Different states at point 1. So nakuha na natin siya. Ano yung sunod? Since given sa atin daw wet region and the polytropic process PVN and 1.21. Okay. Punta tayo doon muna doon, class, sa table 2. Sa table 2. Table 1. Sa state point 2 na tayo At point 2, sinabi doon sa problem that the temperature, the saturation, ano daw, class? Wet region to 100 degrees Celsius. Okay. 100 degrees Celsius. Anong page yan? Table 1. 100 degrees Celsius. Okay. So, makikita nyo, the pressure there, the saturation pressure at point 2 is equal to 0.10135 megapascal. Okay. So, nakuha na natin to. Okay. Considering that this is a polytropic process. Okay. Polytropic process. Babalikan mo to. So, PV is equal to N. So, mangyayari class, P2V2 at state N is equal to P1V1N. Yan. Kasi constant siya. Since alam na natin yung specific volume natin at point 1, alam natin ang pressure at point 1, as well as the pressure at point 2, excuse me, at point 2, hahanapin natin yung specific at volume at point 2 using this equation. Okay? So, deriving this specific volume at 1, okay, yung P1 over P2, huwag mong kakalimutan yung 1 over N. Yan. Kasi class mangyayari dito, diba, group the same, i-grupo mo muna yung specific volume in over V1N equal to P1 over P2. V2 over V1 raised to N. Diba? Hindi yan makakancel. Okay? O, titira to. If we raise the N, 1 times N. Ayan. Cancel to. Matitira sa kabila. Ito na lang. Ayan. So we have now the V2, V1 times pressure 1 over pressure 2. Pressure 2 divided by ratio of 1 over N. Okay? So, this is a polytropic process. Ganito yung gagawin natin. Okay? Since given na, compute for the specific volume at point 2. What is the specific volume at point 1? That is 169.66. 66 times 10 to the negative 3. Your pressure 1. Ano yung pressure 1 given? 1.5 MPa. And this one is equal to 0. Ito kasi yung gagamitin natin. Pressure to. Bakit ginagamit natin to? Kasi stated sa problem that this is that the state 2 falls under the wet region. Okay? 0.10135. Huwag mong kakalimutan yung 1 over N. What is your N? Balikan nyo dito. This is 1. This is your N. Ayan o. Your N here is 1.21. Ayan. Yung PVN mo sa problem is PV 1.21C. O, gano'n na 1.21. Solving for the specific volume at point 2, what is the answer? Sige nga. Sige nga. At point 2, excuse me. At point 2 class, we have Hindi nakuha. Times 66. 1.5. Mhm.
1.57 times.
Okay.
Ah? Opo.
Ano yung magiging answer nyo? $1.27 ano class? So this is 573.05 times 10 to the negative 3. Ayan. Or, you can use this 1.573. Ayan. 1. Lagyan natin ng 1 cubic meter per kilogram. Okay? Ayan. So, finding that, meron ka ng basehan para sa state 2 and stated sa process, it expands 2 kilogram into the wet region to 100 degrees Celsius in a polytropic process. So, we have now, excuse me. So, kukunin natin yung state points. Finding the quality at point 2. So, we have the VF2 plus the quality at point 2. Wala. Times the VFG2. Okay? Or we have now the quality at point 2 minus VF2 all over the VG2 minus VF2. Okay? Okay, in your steam table, gagamitin mo pa rin dito is yung sa table. Sabi mo dito, table 1 point page 3. Page 3 ba to? Ayan, page 3. At temperature mo is 100 degrees Celsius. Okay? We have solved now the 1573.05 negative 3 cubic meter per kilogram minus VF at point 2 is 1.0435 times 10 to the negative 3 divided by VG. You have 72.9 10 to the negative 3 and minus the 1.0435 times 10 to the negative 3 cubic meter per kilogram mass. Okay, compute for the quality at point 2. Oh, answer na. Okay, yung iba. Yung iba. Minus 0.4. Yung iba class. Okay. Thank you, class. So we have now the quality 94.03%. So we have now the basis in point 2 in this polytropic process. So i-compute na natin yung different properties at point 2, U2, UF2, plus the X2 and UFG2. Okay? Point 2, we have the liquid, 418, plus the quality, UFG, 87.6. Compute for the property at point 2. Okay? While waiting for you to complete that, okay, hanapin na natin yung sa iba. 0.04. Ayan. Times 2257. Now your H2 as well as the entropy at point 2. Ayan. Sige nga. Pag na-solve nyo na. Okay. So, what is now the internal energy at point 2? The internal energy at point 2. L, 2381. Yung iba.
2381.86 po sa akin.
Okay. Yan. Entering. Sige, enter nyo muna. So, we have, okay, that is correct, 2381.91 kilojoule. And the enthalpy at point 2. Enthalpy at point 2. What is now your answer? Yan. Enthalpy at point 2. Enthalpy at point 2. We have now. Ano yung ibang
Ma'am,
answer
question
niyo,
po.
class? Yung iba.
Question po.
At point 2.
Ma'am, excuse po.
Ano po?
Ano yan? Pag
Yes po.
for decimal places na lang po yung ginagamit, may discrepancy po sa values.
Ano po?
Kasi yung nakuha ko po, ma'am, di ba, nag-divide po ako ng quality. Tapos, kung ano po, ma'am, yung lumabas sa calculator, yun po yung ginamit ko sa pagkuha po ng internal energy. Parang iba po yung value ko po, ma'am.
Ilan yung nakuha mo, Adeline?
2381.86 po.
0.86 sa'yo.
Opo.
Stick
Tapos nung
na lang
kinumpute
tayo.
ko po, gamit yung for decimal places, same po yung nakuha ko sa kanila.
Opo. Yung 4 decimal places na lang tayo, Adeline. Huwag mo nang i-store yung sa quality.
Sige po.
Okay? Opo, para walang discrepancy. Okay? So, at point 2 class, what is now your enthalpy at point 2? Yung iba, ayan. Oh, may entropy. Bakit entropy na? Yung enthalpy at point 2, ayan. Okay na. So, we have now 2541.30. Ayan, kilojoule per kilogram. And, ayan. Lahat na may answer. Ayan. And the other, ayan. Lahat na nakuha. We have now the enthalpy. And we need to find also the entropy. Entropy. What is now the entropy? Mali yung unit ko. Kilojoule, kilogram. Ayan. Huwag kakalimutan yung unit sa entropy. Okay? So, we have 6.9938 kilojoule per kilogram Kelvin. Okay? So, we have now the state points from point 1 to point 2. So, what is now asked in the problem? Sabi dito, find the letter A, the percent moisture. So, the percent moisture class is your Y. So, we all know that X plus Y is equal to 1, then Y is equal to 1 minus X. So, we have 1 minus 0.9403. We have now the percent moisture. Ilan yung answer natin? Answer, 1 minus 0.94. We have 0 point. What is now your answer? Okay. We have now, ayan, 0.05, excuse me, 597, or percent moisture is always expressed in percentage. So this is now 5.97%. Okay? May 1 point ka na. Nakuha mo na yung sa letter A. Okay, how about in letter B? We are also asked to find the enthalpy, the change in enthalpy. So we have H2 minus H1. But take note, ayan. So this is now, okay, the change in H, ayan, mali na ako. The change in H. But take note, given sa atin yung mass of the steam. If the mass is given, ang hahanapin mo na class is the total entropy, I mean the enthalpy of that. Kaya malaking letters na class kasi we have now the mass. Okay? The mass of steam. What is the mass of steam? Ayan. Expand 2 kilogram of steam. 2 kilogram of steam. So, finding the enthalpy, we have 2 kilogram times H1 ay H2. Yung H2 natin, hindi 2541.3 minus the H1. H1, layo natin. Ayan. 3037.6. 3037.6. So, what is now the enthalpy? Okay. Enthalpy. Negative, positive. Negative or positive? Yan. Okay. Yung iba. Okay. So, since this is a polytropic process, okay, some of the values are negative. Okay. Depending upon on how the steam expanded, okay, so meron tayong negative, okay, 2544.1 minus 3037.6. We have negative, wait, nalula ko. Ayun, 30. 9. Ano question mo answer nyo? 992? Ayan. 41.3. So, we have 992. Ayan, very good. Negative 992.6 kilojoule. Kilojoule na lang kasi makakancel na yung kilogram mo dyan. And in letter C, we are also asked to find the entropy. The entropy. So we have the mass, the change in entropy. 2 kilogram. What is now the entropy at point 2? Ayan, 6.9938. Ayan, Kelvin minus S1 sa taas. 6.9179. 79. Tama ba ako? 91.7. Nagduda si Manon. Tama? 91.79 kilojoule per kilogram Kelvin. So we have now the change in entropy. What is now? Ang bilis. 6.9938 minus 6.9179. We have now times 2. We have 0.1518 kilojoule per Kelvin. Na-cancel yung kilogram nyo. And in letter D, in a polytropic process, we will find now the non-flow work. Since this is a polytropic process, may mass tayo times the pressure 2, specific volume at 1 over 1 minus N. Okay? Given sa atin yung 2 na kilogram, ano yung pressure natin at point 2? 0.10135 MPa times specific volume at point 2. Ano, yun na-solve natin. Yan. Kaya class, pag nagsusolve ka mo, 157.31. Ayan, 1 point cubic meter per kilogram. 1 minus 1.21. Okay? And the pressure at point 1 minus 1.5 MPa. Ano yung given sa atin? Specific volume at 169 times 169.66 times 10 to the negative 3 cubic meter per kilogram. Ito class, hindi ko na to times 10 to the negative 1.57. Okay? Sige nga, pakisolve nga class. Ito na ang flow work. Okay. 0.01. 1.5. Okay, minus. So, maiiba yan yung mga units nyo. Take note of the megapascal, the times 10 to the negative 3. Okay, divided by 1.21. Okay? Times 2. Okay, what is now your answers? Hindi, nahirapan kayo, class. Ako, nakuha ko na. Hala pa. Your MPa times 10 to the negative 3. Pascal is in Newton meter squared. Matitirang units mo is in MPa. Convert mo muna into megapascal into Pascal para maka-arrive ka din sa cubic meter per kilogram. Na-cancel. Matitira sa'yo is Newton meter per kilogram. But since may kilogram ka dito sa labas, matitira sa'yo is Newton meter, which is equal to joule. Okay? If you don't want, you can use the kilopascal. What is now your answer? Ako, I have now the answer. .30. Sige nga, i-double check nyo. Okay. So that is now your work non-flow in a polytropic process. Class, naririnig ba si ma'am? Nakuha ba yung work natin?
Di pa po.
Convert nyo muna yung megapascal into kilopascal para kilojoule na yung lalabasin. Okay. Convert nyo muna yung MPa. Convert nyo muna into kilopascal. So, mangyayari, 101.35. Tama ba? 1, 2, 3 kilopascal times mo sa 1.5731 cubic meter per kilogram. Magma-minus ka 1.5 megapascal.
Excuse po.
Yes.
Yung 2C daw po, may laog kay Sir Balyares.
Sige na, you can leave now, class, yung 2C. Mami po, may pasok kay. Sige, recorded naman po, class. Upload ko na lang. Thank you, class. 2C. Yung 2B. Okay? So, opo, welcome. Sige, class. Matatapos naman to. Okay? Pakita ko lang sa mga classmates nyo. O, 1.5. Tapos, multiply nyo na yung 169 times 10 to the negative 3. 169.66. Kompletohin natin para consistent tayo. Ayan. O, ano pang problema niyo, class, dito? 21 times 2. This is now your work and flow. Okay. Matitira dyan, class, is kilojoule. Okay, yung kilopascal mo is kilonewton meter squared. So, may cubic meter per kilogram ka. Matitira sa'yo is kilonewton meter per kilogram. This is in kilojoule per kilogram. Okay? Nakuha na ba? Class? Yung work non-flow natin, which is equivalent to the 905.30. Nakuha na in your calculator. Is a yes or a no?
No po.
Okay? So, okay, dito muna kayo mag-focus. Yung iba, yung hindi pa, sige, dito. Dito. Paki-compute nito. 105 times 1.51. 101.35 times 1.57. Ilan? Sige nga. 101.35 times. Multiply nyo to, class. Ito. Sa taas. What is the answer? Para by portion tayo. So, 101.35 times 1.57. 31. So, ilan? Sige nga, class. Ano nyo dun sa chat box kung ano yung answer nyo. Ano yung answer nyo dito? Dito, class, 101.35 times 1.57. Yan. Kompletuin muna natin. Yan. Shift store nyo muna. Yan. A. 731. Pakita ko lang, ha. Para mas. Ayan. 433. 685. So, yung kilopascal mo times cubic meter per kilogram. ang kilopascal mo is kilonewton per meter squared times cubic meter per kilogram. Maka-cancel yung meter mo. Matitira is kilonewton meter per kilogram. But take note, yung newton meter mo, 1 newton meter is just equal to 1 joule. So, magiging 1 kilojoule per kilogram, yes. Ayan. Same dito. Minus 1.5 times 0.169. Kinokompleto ko lang class para maintindihan ng fast pace. So, we have 254 minus 254.49. Matitira dito is kilojoule per kilogram. Nakuha ba to class kung paano naging kilojoule per kilogram? Raise your hands if you follow. Ayan. Sige. Okay. Nakuha na kung bakit kilojoule per kilogram siya. So, dun sa baba class, divided by, ito, 1 minus 121. Sige. So, parehas negative yan yung answer, kaya magiging positive yung non-flow mo. O, sige, compute nyo nga yung non-flow work nyo in this equation of the polytropic process. Sige nga, class. In the polytropic process. Ayan. So, what is now your answer? Tama ba yung answer ko kanina? 905.3. So, what is now the answer, class? Okay. Ayun, may nakita na akong tama. Okay? So, 905.30 kilojoule. So, matitira lang na sa atin is kilojoule. Bakit? Kasi may mas pa tayo na kilogram. Dito sa labas, makakancel, kilojoule na lang yung matitira. Okay? Ayan. We move on to the last but not the least. Yung hinahanap sa atin is the heat transferred. So, CDE, we have now. Ay, wait. Saan pa lang tayo? Non-flow pala. Di pa tayo tapos class. Ayan. Ang pinapahanap sa atin is the work non-flow and the steady flow work. Okay? So, pag ganito class sa polytropic, you just need to multiply this by the n. 1.21 times the now of 5.3 kilojoule. So we have now the steady flow. What is the answer? Multiply mo lang siya ng polytropic na n natin. Makukuha mo na yung answer natin into the steady flow process. We have 1,095.41 kilojoule. So, meron na tayong answer sa letter D. Ayan. And last but not the least, we have the Q. The transferred heat plus the work of the non-flow. And compute first for the internal energy. Mass of the internal energy. Mass times the internal energy, 2 kilogram. Ano yung U2 mo? Dito. Haba-haba na. Baka malito kayo, class, pag nagsusulat. 2381.91 281.91. And we have now the internal energy at 0.1. 0.1. 0.1. Ito yun. Okay, class. So, wala yung internet ko talaga. Maririnig yun ako. Okay. So, hindi ko na masusulat dito. Picturean ko na lang class, isend ko. Okay? So, finding the U, makukuha nyo class is negative 800 plus 882.38. And yung para makuha yung heat natin, we have the change in U plus the work of the non-flow. Since negative yung internal energy natin na 802.38 kilojoule, plus the work of the non-flow, 905.30 kilojoule. So yung Q natin, class, last but not the least, is 102.6 kilojoule. So mahaba-haba class in solving the process, mahaba-haba yun class. So nakuha na natin from letter A to F. E pala. Letter A to E. So nakukuha na natin yung processes. Okay? So, ayan, ayaw mag-connect class, so I'm using my data. So, can everyone... So, that is the polytropic process. Okay? So, that is one example. So, yung throttling process class, madali lang naman ito. Okay? So, but before that, ayan, pa-connect na ating laptop. Pero hindi naka-connect yung ating maliit. Okay? Okay, class. So, that is for today.